to change that though. Okay. Okay, so I think we're finally ready. And like I said, this is going to be topic 2 about OpenGL and kind of getting more into that. I can find OBS. Okay. Okay, so again, OpenGL in the Dreamcast is nothing new. Basically, this is going to all be focused on GLdc, which we talked about last time in the first episode, but is mainly I got 2 screens going on over here. So basically, this is an OpenGL driver that Kazad has written in order to kind of unify and provide the #1 best implementation kind of on the Dreamcast that we have. And again, it targets OpenGL somewhere, I think it says, okay, 1.2. Kind of as things allow, we're pulling in things from 1.3, 1.4, and I think 1 or 2 things from 1.5, but generally that's going to be it. The Dreamcast is a fixed function GPU, the PVR chip, so kind of shaders, things like that, is not going to happen. But what we do have is buffers. We can do all sorts of primitives. We can do texturing. We can do multi-texturing in a roundabout way. We can do a lot. We got mapping now support. So it's a really great library, and it comes from a history of many other OpenGL drivers that are available on the platform. So I just want to make sure I'm live here. Okay, perfect. So, oh, sorry. Is there any way I can pull up chat? Okay, so in the beginning, there's always KGL, which Callisto OS provides as the default for now. And that's an okay library. It has some shortcomings. This should supplant that, and then I think there was a GLdc at some point. I'm never going to find it because it's a radio station. Okay, so there's GLdc 2, then that's... I'm not sure when that one existed. I think it's by Chewy. I think this is his site here. He provided one. Okay, so this is even different because Chewy's OpenGL is, again, 1.2, and it's based on GLX. So basically, there's a lot of fragmentation, each one kind of supporting their own features and generally trying to provide that ease of use and simple porting and kind of writing instead of having to learn another API. But they all kind of fall short in a way or another. They're missing functionality, functionality that doesn't match what a PC would be doing. So this is good. This is the project here. It's hosted on GitLab under the Simulant larger umbrella, but it's not. It's its own library. You don't need to use Simulant or anything else with it. It can be used by itself. And master, again, lives here, gitlab.com, Simulant GLdc. And that's the one you should generally use. The API is not going to change. Things aren't going to break. There's not going to be regressions. If you want a stable library to use in either, some hobby project, a game, use that one. I maintain my own. on GitLab as well under Hayden Cow, GLdc. And that one is, we kind of agreed we're going to do a thing where mine would be more bleeding edge, likely to break, and new functionality will hit there first. New changes will go there first. Basically, when I'm playing or hacking on stuff or trying something new or adding a feature, this is where I do it. And things like MIP mapping, I think have made it back to master now. I'm certain they have. But there's a couple other things like some rendering changes, some internal stuff. Generally, again, it would be okay to use this, but you would have to realize that things may change and it might break unexpectedly on you when you are in the middle of a larger project. That can be very frustrating. So kind of, make your own decision with that as well. And more back to kind of what the library is. It's a very simple library. Compiles, you would just link it like OpenGL, and that would provide basically all of those headers. It provides all the functionality, and it should just work as the PC version does. And there's a decent sample set too. The samples were really helpful for Kazad and kind of ensuring that things are working correctly, but also they kind of fell short because the examples were very small. They didn't expose kind of larger issues or when things got really complex, where you started doing things that were definitely fine and legal, not even that, off the wall, but just the library hadn't encountered that yet. So these are good, and they've all been either fixed and things. And like now, shared palettes are there. Quake was helpful in that. New Quake, which is another project I talked about last time, kind of helped us get palette stuff really hammered out and working quite well and quite easily. And then ensuring that we're adhering to kind of the OpenGL spec, because that's already written. So we try and follow that as best we can to ensure that all you have to do is change what library and headers you're compiling against, and your program should just work. In the case of Quake, that was fairly true. There wasn't that many specific Dreamcast things that had to be changed on the surface to get it at least working and rendering mostly correct. And then after that, a lot of work went into optimizing textures, kind of optimizing data formats and reducing the amount of calls, removing OpenGL immediate mode, which would be where you call, GL vertex, GL normal. You're doing each thing individually versus really any other method like GL draw elements, where you give it an array of vertices and indices, and then it would draw those for you. Or GL draw arrays, which you would set up a drawing mode and then just throw vertices at it, and it will draw those as specified. You generally always want to use those. They're way quicker on anything, but especially on the Dreamcast. It's a 200 megahertz processor, and then the PVR chip runs at 100 megahertz, so you're just, you have plenty of time. It's not as slow as it would sound compared to today's, hexacore 2 gigahertz processors, but you do want to try and minimize calls and stack space and everything. But back to the task at hand, and I think I have it here. Maybe I don't. So I was on GitHub. I don't know if I can find the original project on GitHub. Oh, I can. Okay. So I was browsing GitHub just for a sample project to show kind of how easy it would be to theoretically port something over. And this was a good example. It was a simple, there wasn't like 30 source files. There was no assets, and it didn't use shaders. That was kind of what I was looking for, something very small. Shaders, again, aren't going to happen. Some experiments we've been toying with, but it would never be fast, and you wouldn't use it. But it could be a fun toy in the future that we're kind of working toward. But again, it would never be fast. I think my goal for it is like 15 frames a second at best, something of that nature. But again, I briefly talked about this and even demoed it at the end of the last stream, running on the Dreamcast, so you kind of know where this is headed. But this is it right here. Very simple. You do the paddle, you go left or right. You have one ball generally. It bounces all around. It's very simple breakout. And this gives a nice overview as well. This was handy, wasn't really needed. Again, it's such a small project, but it was nice. Your main program entry point uses GLut, which we'll talk about very shortly. The OpenGL utility kit, which is super deprecated and old. Don't use it, please. I guess you could use it, but there's better ways to make a window and manage that and manage your program loop now. GLut isn't your best option anymore. Config.h, just some basic stuff. My objects kind of define what things are. Breakout is where 90% of the logic is. And drawing, kind of the game itself in physics. And menu simply draws a menu. I'm not sure that works. I don't remember seeing a menu. And then some other stuff. And again, no assets, no shaders. I figured it would be perfect. I guess I could show this running. Actually, I think I tried it in my Linux install and it didn't want to run. It was complaining about some older libraries. We're not going to do that. I haven't actually run this on my desktop ever. I guess I could throw it into Visual Studio and get that all done, but that's not really the point of this. And it would just take longer. So from the beginning, this took a little over an hour and a half to do. I did it on a lunch break, and then it kind of ran over because I was eating lunch and doing some other stuff as well. But this was not too bad. So to start off, I forked the project, and I guess we could. I have a pre-built one, but I guess we could start a new one. So very simply, we can clone this repo. Use SSH or HTTPS, doesn't matter. Know why that one's open. Feel free to use your favorite JIT GUI tool, command line, however you enjoy it. So at this point, the repo is purely exactly how it was when Mr. Osama Atiya wrote it. Nothing Dreamcast specific. Purely, I think he ran it on a Mac, so that would be everything there. So the first step was, and at this point, we're going to switch back. I'm sorry, I was going to go through and type this out, but I don't see the value in it, especially when it's already written and I can kind of interactively show you how it went for me. So first step, I did add my GLdc as a submodule to this project. I can show that because, and there's some simple reasons for this. The library, you could definitely it has a cost port script, so you could download and use it as a cost port and install it into your local Callisto OS or COS installation, and it would replace your OpenGL, and that would be great. But if you're using things like Docker, or you don't want to necessarily touch your installation, submodule is a great option. Because oops, I have it backwards. Because you wouldn't have to touch anything, you could maintain your own branch, and you wouldn't have to worry about constantly I don't need the all. Okay. So now we have my branch of GLdc locally in this project folder. It's not really a project, but it is. And then the next step was Osama used CMake, which is great. I have no qualms with that. It just seems a little heavy-handed for me for such a small project, and I don't have a CMake configuration ready at the moment. I know Kazad does for Simulant, and I've kind of used that before for one other thing, but so we're just going to write a simple makefile. I think that's much easier and much more fits the scope of what the project is, how large it is, and kind of the time frame as well. So we're going to jump over to VS Code, and this is a template, which I guess I can throw up on GitLab as a snippet, I guess, as like a basic template. You could use your own. Callisto OS provides much simpler, shorter ones. It's really up to you. You know, however you want to do it, that's fine. But this is what I like. It's very simple. Everything is spelled out really easily for you. And, you know, again, I just think it fits better for this. So at the top, we're going to just define some basic flags. You could ignore all of this and yeah, so you could ignore these two. You could change the compiler to cos-cc, and likewise for C++, you could do cos cpp. I think it's C++ actually. And that would set up all your flags for you and a couple other things, make sure your environment's good. I don't like giving up the control of the compiler, and also I don't necessarily always agree with the Callisto OS default flags. So I don't use it. You're more than welcome to. I encourage you to. Callisto OS would encourage you to. It's one of the things where, unless you have a reason not to, you might as well just use it. You know, I don't know. I don't like it. I like calling the compilers myself and knowing exactly how things are compiled. And again, since this is a template that I use for a lot of different things, sometimes when I'm not even using Callisto OS and I'm just writing plain assembly or C for things, it just makes more sense to have that. Basically, the top, just redefining some string compares because this program uses different versions. We're defining for Dreamcast. That's really awful. Fast math, we're going to optimize unroll loops. We need all the warnings we can get. And then these two are directly related to how I've kind of set up my branch of GLdc to compile whether you're going to build it as a library to be used across many things, or whether you're just going to compile it and then directly use that in an application. There's some benefits to both, but this will basically set it so we, the program and GLdc know that they're just going to be built for this program. We're going to define where the libgldc library is, what we want to call our binaries. Game obs is just going to be all three of our source files that we're going to compile. It's kind of complicated. Basically, we're going to compile everything with this line using all our flags and a couple other things. And then these two do the dirty work of taking a ELF, which is just a binary format that our compiler is going to give us for a final binary, strip off everything we don't need, put it in a flat format, and then also scramble that so that when we put it onto a disk image, we don't have to do anything special. The scrambling procedure really unscrambles it so that when the Dreamcast scrambles it as part of its protection, it's back to how it originally was. It's very slick. This line for GLdc, we're just going to recursively go into that other directory and build GLdc so we have it available. Refresh, just going to remake it. Here's how we compile things, and then clean would just be to delete everything. And today we're going to be using Docker. And this is going to be our command. It's very simple. It uses the same Docker image I talked about last time. It's still public. I think I pushed the updated one with one small fix. Doesn't really matter which one you use, but the new one is slightly better for complicated reasons. Docker run, we don't need to keep any temporary files, and the -v is going to say we're going to mount our source directory to /source, which would be where you would want to mount everything on that image, the root /source. What image, what tag release, and then our actual command, which would be make or make clean, or optionally we could make refresh, make GLdc, and that'll be great for our makefile. And so actually, let's dive in. This is the history of the entire project, and we're just going to go through it. So main left for this whole example is going to be the original, and right will be the Dreamcast port. Basically here, we defined headers, and we're going to define our own headers. This is kind of done in too many places, but again, this was fairly quick. Basically, if we are defined as Arch Dreamcast, which means we're compiling for Dreamcast, we just define, we're going to include our OpenGL files. Glut would include these for you if you're using it, but we aren't because it doesn't exist. So we have to add those includes ourselves. And basically this is just changing how and where we're saying they are. Since we're building libgl locally for this project, they're going to be local, versus if they weren't, they would be global includes. That's fairly basic. And then in our main here, very simple for right now. Basically, if we're on Dreamcast, do literally this, which would be nothing. Otherwise, do this, because we don't have any of these methods on the Dreamcast, because again, we're not using glut. The only one we would have would be game.init, but we'll come back to that. All of these are unimplemented because that library doesn't exist. think this one's very much the same, just a header change. All we did was add our OpenGL headers. Nothing big there. And this would be the main game. Breakout.cpp is kind of what I touched on earlier. So where all the meat of the entire program is, from rendering, displaying, logic, controls, it's all here. So again, we're just commenting out everything glut related because we don't have it and it's going to error. So basically, I just went through and looked anywhere there was a glut method. I just wrapped it so we weren't going to use it. For draw background, this one I just kind of knew. I mean, it wouldn't really matter if you left it in. It's a no operation. It's knocked out, so you could call it and it would do nothing, but it would be an extra call that you don't really need. Hopefully it would be optimized out. Either way, it doesn't work. It's not needed. Same thing here. Change the polygon mode again. It's not going to happen because it doesn't exist. Same thing, comment out that. Text rendering is kind of a not necessarily complicated topic, but it kind of writing a text rendering class or engine or just any methods for it kind of, again, goes beyond the scope of this example. So there's no text rendering. And yes, it is a glut method, but it's more, we'd have to load a texture, we'd have to define where our letters are. There would just be a lot of extra things just for the, I think it's only 1 or 2 spots where text is even used. Yeah, it's literally just this score bar. We don't need it for now. It would be nice if it came back, definitely. Probably also thinking of it now why the main menu doesn't work, because we don't render text. So that'll be at a later date, kind of an expansion on this. So I want to go back, add sound, text rendering, maybe saving and loading high scores. So I think that would all be good. But for now, again, just removing everything, glut, and then we get to another very important step, input handling. The Dreamcast does have a lot of ways for input. It does have a mouse, it does have a keyboard, it has controllers, fishing rods, light guns. Thing is, most people have standard controllers, so it should always be your goal to support a standard controller. You know, there's no reason why you shouldn't. Just try as best you can, even if it's not the most optimal layout, a controller should be supported. But anyway, for now, we're going to remove all the input handling because we haven't written it yet. And we actually come back and deal with that in a decently handy way, I think. So that was step 1, and can I actually check? Ooh, that failed. Okay, that's fine. Okay, so that's not actually going to work. That's fine. But basically, at this step, all that happened was it compiled and then ran, and nothing was shown on screen because we weren't displaying anything. So the next step was rewriting the game loop. which could have been done nicer. We could have actually checked if we're hitting 60 frames a second or 30. But this was simple enough and again worked great. So our first step, GL costs in it, and that's provided by GLdc. It sets up all our buffers, sets up rendering, enables the graphics chip, sets up everything it needs. Call it once. It has defaults, and that's that. You can actually customize how that initialization happens, but if you don't need to, defaults are great. And I believe now, even in Quake, the defaults are used because just kind of drove that. Then we do call game.init, which is provided in breakout. And then we do a while loop. We call the game's render method, myDisplay, and then we swap the frame till forever. Not very elegant, but worked great. Okay, I actually would like to check that out though. Okay, so that is going to be good. Okay, so let's build that. This should work, hopefully. And again, this is the step at which we have no input, but we should be displaying something. This is kind of how it goes in steps. It's good just to verify things are working as you go through. That's not going to be right. And I can kind of go at the end of this, I guess, an update, because I've been working on some other things too. Nothing hugely interesting or great, but just more interesting things. Okay, so here's breakout as it runs literally at this point, and all we did was remove everything glut related, keep everything OpenGL related, and don't touch any of it. And then all we did was added these lines. We initialized GLdc, initialize the game, and then we display it and swap the buffers. And I think that's a huge win for the library, and that may not even seem like the biggest thing, but again, just knowing that this program, nothing rendering wise had to be changed. Nothing. Let me get those lives back. Okay, one more time. That's too slow. But I think that goes to show how well the library is and what kind of compatibility. Okay, this is perfect. So if we compare this to Osama's running on macOS, what is going on here? We can see we have the same background. We have our paddle. All our bricks have this two-tone shade exactly like that. We have a colored ball. We have hearts rendering. We are missing this line. We could draw that with a quad. We used GL lines, which aren't supported yet. They might be at some point, but not right now. And lost our thing. And it generally looks very close, and it runs fairly well, I think. Yeah, so right around 60 frames a second. So it's perfect. But again, we have no input. but we do have a working game. So that was a great milestone to reach in about 30 minutes. Basically cloning it, writing a makefile, removing glut, and then just seeing what happens when we ran it. So back to our code, back to seeing more evolution, because in the video I showed, like, it was obvious you could play the game. So, but at this moment you can't. So what was needed next was to get actual input and see, not see, but kind of get input from the player on a regular Dreamcast controller, and then have that control the game without really changing the control of the game or any of the game code itself. Because again, it's a port, so you would ideally only change what you'd need, and you wouldn't have to dive into things. So basic changes, we included cost.h, which is the master header for CallistoOS, ensuring that we just have everything related to sound, rendering, input, sleeping, texture loading, basically anything that CallistoOS provides, which is really everything. It's huge. And so we just want to make sure that that's included, and we're going to need it for our control things anyway. And then down here, I guess in the end I do have to talk about glut. I was hoping not to. But, okay, so glut basically works. Really, this is going to be the quickest, worst overview you could get. Basically, it initializes. You tell it how you want it to render. You make a window on whatever operating system, whether it be Windows, Linux, Mac, whatever other kind of supported operating systems it runs under. You could probably write a really basic, lame, single file glut replacement for the Dreamcast. I don't really see what benefit it would be. It would just kind of clutter your code because you would have all this. I don't know. Maybe that'll happen, maybe not. We'll see. I don't think it would be long at all. And then you set up pointers to functions, and then glut will call those for you when appropriate. So it's kind of overarching and manages everything. But on the Dreamcast, it doesn't really matter because you can only have one application running at a time anyways, and whatever you're running is in complete control of the entire, complete control of the entire system. There's nothing above you. There's no OS. It's just your code and what you're running. So having a glut-like thing or glut replacement that would be calling functions when things happen doesn't make sense, because you would ultimately know when things happen because you would be generating the things happening, if that makes sense. Anyway, glut display func, basically every time glut wants to update the window, it calls that. Every time the window is reshaped, never happens on Dreamcast, we call that. Mouse clicks would happen on that. Dreamcast has a mouse, we're not using it. Yeah. Motion and passive motion are when you move the mouse. Again, Dreamcast supports a mouse. You can support a mouse. Most people don't have one. They run $20 to $30 to $40, kind of depending how you set up your mouse. Yeah, it's not the greatest expectation that people would have one. Glut keyboard function, every time you hit a key on a keyboard, this would get called. Again, Dreamcast has a keyboard, same price, $30. Not everyone has one, don't expect it. Special function, I guess that's like the F keys and such. Again, keyboard issue. And then glut main loop. basically boils down to a simple while loop. It would call your update. It would check if your window's resized. It would take in your inputs. Yeah, I don't know. We don't need it. But that's where these two methods came from. My keystroke and special keystroke are directly copying the original ones Osama wrote, my keystroke and my special keystroke, except now they're Dreamcast specific and they work from a controller. And this is the part of the tutorial where this is straight up only related to Dreamcast dev. This wouldn't be something you'd encounter somewhere else because this is how a really easy way to get input from a Dreamcast controller. And yeah, it's how I like to do it. I think most people do it this way. Who knows? We can go line by line. We define a simple integer, 32-bit, to hold our buttons, because that's what GLdc provides. I can show the documentation. It's not really that helpful. We define a pointer to a Maple device, which is a device that could be plugged in that provides input on the Dreamcast, and then controller state gets the state of whatever input device is at that moment. We ask for a type of Maple device called controller, because that's what we're looking for, and that's what most people have. If we don't find one, we return, because we can't do anything else. If we did find one, let's get the current status of that device. We're going to store that in state. State provides us for controllers a really handy property called buttons. We're going to store that. But buttons doesn't include triggers because they are axis values. They go between, they're like sliders basically. They could range between 0 and 255. But sometimes you don't need that fine grain of control. You just want to know if they're active or not. So that's what we're doing here. Just if the trigger is pressed even a little bit, we're going to say yes, that now button is on. It's not used in this program, but it's just, again, template code I had written, so it's here. And that's really handy, again, to just kind of make the triggers a button, in a sense. And then the actual magic of this, and to where we didn't have to change any of the actual game code itself, this is saying if buttons and controller start button is true, basically if someone is pressing the start button on a controller this frame. We're going to call game keystroke n for a reason that'll be really apparent in a moment. If buttons and they're pressing the Y button on the controller, we're going to call Q, and then if they're pressing X on the controller, we're going to say H. And those seem really arbitrary, and they kind of are. But if we go into, can I just click it? Okay. If we go into keystroke, this is what Osama had written. And so instead of changing anything, it was just easier to copy exactly what he had written and change our new input handling to take our input from the controller and GLdc and then output whatever the game is expecting. So we're kind of just modifying that input and massaging it into what the game expects. I think that's the best way. That's how I did it for Quake as well. Yeah, it's easy. And he had defined Q as exit, so I think I put that as start. It's gone forever. Yeah, who knows? I can't find it. Whatever. Start was exit. I think Y was N. I can't. This is going horribly. Yeah, okay, so start was new game, which he just had as case N because he was expecting you to press on your keyboard the N key, but we're just going to call it and send an N when you press start. Sorry for that, got really confusing really quickly. Y is going to be Q for quit, because that's what he had written there. We don't have an escape button, so that'll never happen. And then we had set X on the controller. It's a little cheat, basically. He had set it if you press the H button, oops, on the keyboard, you would get extra lives. So I just mapped that to X. Very basic, very simple. So that's kind of why those values look like that. You know, obviously in your own game, you could call, you know, game.handle start if you wanted, if it was written like that, or, you know, you had an input handler and it would take like an enum called start. You know, the part in these would really be dependent on whatever you're doing. But the basic focus on how you would map someone pressing a button to making something happen would be this. Oops. And then we come down to my special keystroke, which again, that's what Osama had written, so I just called it Dreamcast my special keystroke. We kind of went with that. Same code up top. We get a controller, we get the state of it. It's these same 3 lines, same 5 lines really. And, sorry. Whoa, what was that? Well, please, okay, well. Sorry, I'm getting crazy. Okay, so this is basically wrapping the arrow key input, which is how our paddle moves. Obviously, for breakout, we need to be able to do that. And this code looks a little different, but in a way, it's much the same. And we're basically saying, if the first joystick we hit, if on the analog stick, somebody moved it to the left, then we would read that we're going to tell our game, hey, we moved left. Same thing, if it goes to the right, we're going to say, hey, the user pushed something and we go to the right. I know I said we removed everything glut, but we didn't. And I'll kind of show why in a second. Thankfully, glut key left and glut key right are just defines, which basically mean they're defined in code as something else. But for the humans, they're easier to read. And that was basically all the change that happened here, which is 90% of how that input handling was changed. And back in breakout, we did the same thing. We added our cost header. And then we just defined key left as 1 and right as 2. They're arbitrary. You could have defined them as whatever you wanted. I just did not want to have to change the game code itself, and this was a simple way to do that. Same thing with this one, defining glut post redisplay. We just define it, but we don't define it as anything. So in the code, that basically is empty. Whenever it's written, nothing happens. And then we define maple and maple controller, which would be for input handling. That's where cost provides those two, and that's in the documentation and samples. And nothing else had to change, which I think was great. And then in our breakout file, which is where most of the game is, we originally had commented out this whole method, but now we brought it back. And it's unchanged from what was originally written. So nothing had to change there. Same thing in special key pause, and that's why we defined glut key left and glut key 1 instead of changing what they are, because I didn't want to have to change the code. And then defining glut post redisplay as nothing ensures that this doesn't have to change either. We could just leave it as is. And so this file, basically the only changes are we still don't have mouse control. We could add that in with GLdc. That might be at a later date. Again, not really a huge feature because what? How are we back to this song? Oh man, the music, whatever. Something background noise. And then we could show that off. The mouse handling in GLdc is actually really easy, not hard at all. You get movement on an X and Y axis. You can either do relative or absolute. You get left click, right click, scroll up and down, and middle mouse scroll click. So it's pretty powerful, but not everyone has one, and you shouldn't expect that everyone does. So we can hopefully, let's see, hopefully check out this, and we should just be able to, I guess I don't have to do that every time. Makes me feel better though. And we can see that we should have control now using our controller, and all of this is being done in GLdc and emulator. In the last video I already showed it working on a direct capture from my real Dreamcast, so it's just easier to do it in an emulator rather than, you know, hook up my Dreamcast, set up the capture software, and have to switch. And we can't move. Okay. Oh, we can. Okay, it's the wrong buttons. Okay, let me try that again. I forgot I had it mapped to the analog stick and not the D-pad, because generally I use the D-pad for stuff. Okay, analog stick. So, game works, we can move. What is X button? Oh, okay, so that's the X button, and we can see we just gave ourselves a ton of lives, so that's working as well. We gave ourselves too many lives because now they're not going down. But anyway, so that's a huge success too. We're basically able to take GLdc's input and wrap that and then provide it to the game, and the game doesn't really have any idea that instead of a controller we're using instead of a keyboard we're using a Dreamcast controller, and it's still happy and we didn't have to change anything else. Okay, and then if we hit the Y button, I think it crashes, honestly. Yeah, okay, so it does crash. So, okay, so new game doesn't work, or exit doesn't work. Either way, not a huge loss. The game itself does work. So then just some other minor things. I kind of went beyond. Back in the my keystroke file or method, I set it so this is our right trigger fake button, if you will, that we set when the right trigger is pressed will end up true here. And there was this cheat somewhere. Let's see. It's got to be here. Okay, well, somewhere there was a cheat to add another ball. Can't remember where that was, but so I just copied it here and I set it on right trigger. So when you press the right trigger now, you'll get an extra ball on the screen, multi-ball. And then back in my special keystroke, it didn't make sense that you would have to 100% use the analog stick. You know, maybe you don't like the analog stick, maybe it's broken, maybe you have a fight stick, maybe, you know, a million things. So I just also added that the D-pad will also control. So I think that makes more sense. You can use the analog stick or the D-pad. I don't know what happens if you use both. Nothing should happen. And so that was two other kind of minor changes that I thought made things better for the people who actually played this game. It'd be odd, but no. Who am I to say? Oh, maybe I added this myself. And then all I did was apparently move new ball from private into a public method so I could call it. And that's the one big change, I guess, to the game, is that I added in a cheat for extra balls. Awful, I know. Okay, so that's where it came from. In the original game, if you click the left button, you would get a new ball. And I just set it the right trigger. So not a huge change. Just kind of had to change how things were laid out in order to accomplish that. You can copy this one, and it doesn't really make sense to show. Well, I guess we could show multi-ball. And actually, you know what? I don't think that's gonna work. That method changed. That should have compiled because breakout had one of its members change visibility. Who knows? Whatever. So now I can use in this emulator or on a real Dreamcast the D-pad, and then I think I map this as trigger. I'll try and get it up top, and then I'll hit that. Not gonna happen, is it? Oh. I'm not very good at breakout, if you can tell. I crashed the whole thing. Okay. We're just going to hit it immediately then, because I can't last long enough in breakout to do what I want. I give myself a ton of lives. Let me see. Oh, come on. Oh my gosh. Okay, well, whatever. Here's the extra balls. So that works too. It does slow down a little. It doesn't slow down as bad on hardware, like an actual Dreamcast. There's still some slow, but it's not too bad. So that's basically how I took Osama Attila's breakout and ported it to the Dreamcast and gave input, added back his cheats, never fixed the crashing issue when you hit start game, didn't add text rendering, and we're still missing that one bar. But at a later date, I think it would be good to kind of expand this as a decent example from this tutorial, to add sound when you hit the balls. Maybe an actual working title screen, fix whatever jank is going on up here. I don't know, some serious jank. I think they just get like stuck or something. it's got to be a logic thing where one check is under and the other one is exact, and it just kind of bobbles between both and they get stuck. But that was breakout. And again, the code lives here. I really should be able to copy these, but I can't. Oh, wow. Sorry, I'm trying to type this. Yeah, and that should be it. I guess some minor things kind of that I could talk about really quick. New Quake. Okay, whatever. New Quake reached a point where I felt comfortable taking it out of alpha, so now it's in beta and it's kind of more general release. It's way faster now on a Dreamcast. It's the fastest Quake 1 render, like full hardware rendering one we have. I fixed all the text rendering, rewrote all that. Menus are rewritten so they look perfect on Dreamcast. Less lag in the starting area. It also supports widescreen now if you need. Saving is still broken. That's kind of the last thing I'm going to work on. You guys can't hear this, but I can. It's really annoying. Sound works fine. I just don't need it right now. And dynamic lighting still working. It works on hardware just as fast. So that's first for Quake on the Dreamcast as well. Oh, if I could play it. Oh my gosh. I think shadows are broken still. Let's see. Throw up a shadow real quick. Okay, so shadows are there, but they render white instead of black. Something's not right there. Could probably fix that. Wouldn't be too bad. So shadows should be fine. I think this is still set to render in widescreen, so that's why it looks squished if you're super familiar with Quake. There's all those dynamic tech shadows working. So dynamic shadows and explosion effects work again. Yeah, it's really kind of a joy to play on Dreamcast now. Sound is great. Skies are back. I think water effects are working too. Let's see. I know all the effects are. So this goes blue like it should. These turn on and off when they should. Who's shooting? So those would all have shadows soon. But the game itself runs pretty well. It runs most mods that I've seen. I don't think I've seen one yet that doesn't make it to the title screen. Not all of them kind of go in game, but they load decently well. Here's the underwater effects. Kind of got a lot going on, so everything's moving. But then also we have green because we have the biosuit on. And so this project actually shaped up really well. Super happy with how that all went. More different color and still the water effects and moving everything. So, oh, come on. And this screen is fixed on Dreamcast as well. There used to be issues kind of here where all these were, where there was some strange depth issues and kind of transparency. That's all gone. That's fixed. All in all, really happy. I'll show one other thing. Somebody mentioned me this game. It doesn't work, but I can at least show you it almost looking decent. It's Shrek. It's some commercial Quake mod that looks a little jank. It's not loading the right demo. But this is the intro, which does actually load and run really well. It still has this fading effect. Yeah, we're pretty happy with all of it. But then it crashes when you go in game, so it's like, whatever. It's not that great. This is like 2 frames a second with dynamic lighting. You turn off dynamic lighting, we actually get some speed, and things actually don't look too bad, but then you go in the next portal and the game crashes. So it's less exciting. But it, maybe it could work with a little bit of fixes. This works and everything. What does that do? Toggles bug war mode. Toggles particles. Let's see who's playing. Okay, wow. Okay, that's kind of neat. Okay, so that works. All your favorite Quake mods should likely work. There's a Matrix one, it works. Airquake works, but it's slow. Quake Rally works, it's fine. Kickflip, it's like a skateboarding mod. That one's my favorite, and it works fine. So yeah, I hope we can get that released. Should be great. Everyone loves it. That's all. It's decent. I was working on something else too. Oh yeah, back on the Mill CD project. Show that real quick. I just was kind of I Google a lot of stuff, and I found this forum, Reset Era, and they were talking about this series, Growlin no Torikaku Capital, whatever. And I mentioned, I ran across that when I was doing a different project. So I'm helping them. Maybe something will come of it. I think they're planning to do a subtitled or even English dubbed re-release of the entire series, which is kind of impressive because it's like 365 minutes of video, so that's pretty long. It's like a 5-hour. Maybe it's longer. I don't know. Either way, it's 5 to 6 hours. I'm not sure every disc is 60 episodes, but so they're planning to do an English somehow release of all of that, and I'm going to be helping them. Could be cool. We'll see. I think that's kind of it lately. I was doing some other stuff, but it's kind of too early to talk about. But stay tuned. We'll have more. Leave comments and feedback. Check GitLab if you need any code. Always on the, pull it up probably, the Simulant Discord. Guess probably somehow get a invite. I don't know how. Actually, I don't think I can. Okay, well, I guess I can somehow. So I can toss an invite to that. Only on YouTube because that's just how it's going to go. Broadcast to my Twitter followers. Okay, well, I don't know how to do that, and I don't have a Twitter, so no. But yeah, so on the Simulant Discord, that's basically where all the development kind of happenings for GLdc go. If you need help, if you have suggestions, if you want features, if something's broken, if you want to add something, that would be a great place. GLdc is a little early, but we're getting there. It's also where the main Simulant development happens in public. Coding, we just talk about really any sort of Dreamcast code we're doing. In Lounge, we throw around a ton of ideas and other Dreamcast stuff. Yeah, I don't know. Join it. It's a lot of fun. We'll help you out. And that's basically it. I just kind of wanted to go over OpenGL and talk more about that and how you would port something, and show that you can take an existing application and change really nothing important about it. Nothing OpenGL specific or really input specific had to be changed for breakout. Just changed a little bit of kind of how it runs, and then we massaged our input into what it expected, and everything was fine. Now, of course, it's 2D versus 3D, but that it doesn't matter. It's all going to work the same, because 2D is basically just 3D, but only in one axis. Yeah, you get the point. So thank you so much if you came and watched, and have a great day.